Let's do some calculations with exponents in geometry. So by now, we should have been familiar with the idea that if you have a number being multiplied over and over, that would be considered an exponent or a power. So what we want to do now is take that understanding to calculate a few things. The area, the total surface area, and the volume for a few of these cubes. So let's start off with B for visual purposes. So the first thing we want to do is find the area of a face. So how will we find the area of a face for this cube? Well, any of these sides could be considered faces. And we should know that a cube has 6 different faces. So if I'm just focused on this face right here, that is the shape of a square. And we already know that to find the area of a square, we normally say length times width. But what we want to do now is realize that this 4 and this 4 are exactly the same. So in other words, in a square, all the sides are the same, and it's the same for a cube. So instead of saying length times width, I can call that S times S. I'm going to call it the S side. Side times side. Length times width for a square, side times side. It means the same thing. So what we do now is just say, well, if we know how to rewrite repeated multiplication as a power, then this will be written as S to the second power. With that understanding being true for all squares, I no longer need multiple sides to find the area of a square. If I was to cover up this 4, if I didn't tell you that this was a 4, it wouldn't stop it from being a 4. You would still know that because this side is 4, then this side must be 4. And since it's a square, all the sides are the same. So instead of having to find another side, I can simply say that the area of this square or of this face is simply 4 to the second power, 4 squared. We know that 4 squared is 4 times 4. And we know that 4 times 4 is 16. And technically, I don't even have to write out 4 times 4. If I can write 4 to the second and then I go to 16, there are no issues there. So that's how you would find the area of a face on this cube. I don't need multiple sides. I just need one of the sides. The next thing that I want to find is the surface area, the total surface area. The surface area, I'm going to call that SA. So the surface area, SA, is the area of all of the sides put together. So remember, if you broke this cube open or this box open, there'd be 1, 2, a third side on the back, a fourth side on the left, a fifth side on the top, and a sixth side on the bottom. So there are 6 sides, but a cube, for a cube, all the sides are the same. So if I know the area of this face is 16, and all of the other sides are also the same, and there are 6 of those other sides, or 6 sides altogether, then all I would have to do to find the surface area is take the area of the square, which is x squared, and multiply it by 6. So 6 times s squared. So in other words, this would be 6 times 4 squared, which is really just 6 times 16, which we know that already, and 6 times 16 would just be 6 times 6. 6 times 10 is 60. 6 times 6 is 36, so altogether that's 96. So the surface area would come from finding the area of one face, which in this case is 16, and multiplying it by 6, because there are 1, 2, in the back 3, left 4, top 5, bottom 6 sides that will all also be 16. Alright, so the last thing we need to be able to find for this one cube, now mind you, again, if I got rid of this right here, if you didn't know that this was a 4, if I didn't tell you it was a 4, you would still know it's a 4 by virtue of the fact that it's a cube. So really, they only have to give you this one side in order for you to figure all this out. So let's do the last thing, volume. The volume, which is going to be V, the volume, if you use your reference sheet, or you should know, is just the length times the width times the height. LWH means length times width times height. But again, we go back to the same idea that in this cube, all of the sides are the same. So if all the sides are the same, I don't need 3 different variables because they're all the same. So once I know the length of one side, S, I know that it's being multiplied 3 times. S times S times S. So that would then be S to the third. And what we need to do is get to a point where we know automatically if it's 3 S's being multiplied, that's S to the third. So now I need one side. I don't need multiple sides. I don't need to know what the other sides are, because if it's a cube, I know they're all 4. So I take that 1 4 and say 4 to the third power. And that would be the volume. If I chose to multiply it out, then we know that that's 4 times 4 times 4. And then that would be 4 times 4 is 16, and bring down the other times 4. And 16 times 4. 4 times 10 is 40. 4 times 6 is 24. And so then that would be 64 altogether. So my volume will be 64 inches cubed. My surface area will be 96 inches squared. And my area will be 16 inches squared, and that's the area for one face. Alright, so why don't you give that a try and calculate the area, total surface area, and volume for D. So hopefully you were able to first, when we say you're looking for the area of a face, we know again, we're just going to take any one of the faces. It could have been any one of the 6. I could have done this one. I could have done this side here. I could have done the side on the top. And again, one of the things that we now know is that I don't even need to know all of the sides. So if I hid this idea here, if I was to completely get rid of these numbers here, you would still know that they should be 5s because of the fact that you know that this shape is a cube. So I don't need to see all the sides in order, or the measurements of all the sides, in order to be able to do calculations. So what would the area of the face be? Well, it's going to be the area is one of the sides raised to the second power. So S squared, instead of S, I'm going to write a 5 now, and that's 5 squared, and 5 squared is 5 times 5, and 5 times 5 is 25. And again, I don't need to write 5 times 5. I can write 5 squared and go straight to 25, and that's no problem. If asked for the surface area, once again, because we're dealing with a cube, we know that the cube has 1, 2 in the back, 3 on the left, 4 on the top, 5 on the bottom, 6. And if one of the sides has an area of 25 millimeters squared, then all of the other 6 sides have an area of 25 millimeters squared. There's a 25 on the back, there's a 25 on the left, and there's a 25 on the bottom. So since all 6 sides have an area of 25, I would just take 25 and multiply it by 6. And that would be the total surface area. 25 times 6, 6 times 20 is 120. 6 times 5 is 30. And so that would be 120 plus 30 is 150. And I'm done just that fast. I didn't need to do a whole lot of calculations because I understand at the core what it means by having a cube. The last thing that we'd want to find is the volume again. The volume is supposed to be length times width times height, but for a cube, because all of the sides are the same, I only need one side and raise it to the third power. So s to the third, since it's 25, since s is 25, I'm sorry, not 25, 5, since s is 5, I'm going to write 5 and raise that to the third power. The whole purpose of this is getting you to see that you can write this more efficiently. So 5 to the third would be 5 times 5 times 5, and 5 times 5 is 25 times 5, and 25 times 5 is going to be 5 times 20 is 100, 5 times 5 is 25, so 125 altogether. So the total volume is 125 millimeters cubed. So that's really all that you need to be able to do. Find the area of one of the faces by taking the one side and squaring it. Once you know the area of one side, to find the surface area, you just take the area of one face and multiply by 6. To find the volume, you take the length of one side and raise it to the third power. And that will tell you the volume for a cube every time. So why don't you go ahead and try out letter A and letter C, and hopefully we have this mastered. And if there are any issues, then go ahead and reach out.